Hello students. So continuation of types of functions. In last video you learned two types of functions. Continuation of that. It's called bijective function. Okay, how to define? See here. A function f from a to b. A function f from a to b is called a bijective function if it is both 1 1 and onto. If the function is both 1 1 and onto, then such functions are called bijective function. Such functions are called bijective function. So remember, the f must be both 1 1 and onto. See, if I explain this first diagram, okay, using the diagram, observe this carefully. A and B, 1 2 3 4, A B C D. So to this function, okay, is a bijective function. To say it's a bijective function, then the connection should be like this. Every or different elements of the first set are related to different elements of the second set, and every element of the second set must be connected to the first set. When the connection is like this, say this function is a bijective function. Okay, there is a one-to-one correspondence. This is actually called, okay, one-to-one correspondence. Okay, if there is a one-to-one relation between the sets, then such functions are called bijective function. See, for example, if I take f from R to R defined by f of x is equal to 2x plus 1, then this can be a bijective function. Here check ಮಾಡೋದು, observe carefully. First one hodal one check ಮಾಡಿ. F of x1 is equal to f of x2. Correct? No? 2x1 plus 1 is equal to 2x2 plus 1. So 2x1 is equal to 2x2. 2 cancel, you will get x1 is equal to x2. So two different images and different elements, or if images are equal, elements are equal. So this shows that f is 1 1. This shows that f is 1 1. Next, f is onto. Okay, f is onto. Take f of x is equal to y. What f of x? 2x plus 1 is equal to y. This implies 2x is equal to y minus 1. This implies x is equal to y minus 1 by 2. Now, is it this belongs to R always, or is this function is always a real number? Obvious, because 2 cannot be 0. This is not real only when the denominator is 0, but denominator cannot be 0. There is no square root, it cannot be imaginary. So it is always true for all y. So f is onto. So f is 1 1 as well as f is onto. So f is called bijective. Then f is called bijective function. This can be an example of a bijective function. A function if is both 1 1 and onto, such functions are called bijective function. So these are the three main important types of function: 1 1, onto, as well as bijective. Now we are going to solve some problem from exercise. Okay, this exercise is purely based on 1 1, onto and bijective. The first question in the exercise is, check the injectivity and conjectivity of the following function. I am using two different words here, injectivity and injective or surjective. Okay, see, injective function anta helidrenu 1 1 function, surjective function andre onto function. Nenpilli. Okay, 1 1 function is also known as injective function. Onto function is also known as surjective function. When it is both, it is called bijective function. So it is called bijective because of these two words. Okay, remember, example injective ಅಂತ word use ಮಾಡಬಹುದು. Don't get confused. It is 1 1 function. Surjective andre onto function. Okay, the first problem under this heading is f from z to z given by f of x is equal to x square. Z to z. Z andre ಏನಿಲ್ಲಿ set of all integers. Z andre set of all integers. Nenpilli. Z is nothing but set of all integers. So first you have to check whether it is 1 1 or not, or injective or not. So ಹೇಗೆ ಬರೆಯೋದು, ಒಂದು ಪ್ಯಾಟರ್ನ್ ಇದೆ, ಅದನ್ನೇ ಫಾಲೋ ಮಾಡಿ. Remember that. First write the heading. Okay, whatever you take, you write the heading for that. 1 1. 1 1 ಹೇಗೆ ಚೆಕ್ ಮಾಡೋದು? If the images are same, then you have to prove that elements are same. F of x1 equal to f of x2. F of x ಏನಿಲ್ಲಿ x square. So ಇದೇನಾಗುತ್ತೆ, x1 square is equal to x2 square. Take square root on both sides. x1 is equal to x2. ಹೌದಾ? No, it should be plus or minus, because z contain negative integers also, and when you take square root on both sides, you should write plus or minus. So x1 is equal to plus or minus x2. This implies x1 is not always is equal to x2. When x1 is equal to x2, if x1 is equal to plus x2, then they are equal. If x1 equal to minus x2, then they are not equal. So it is not equal always. Remember that x1 is not equal to x2. Therefore, what is the conclusion? F is not 1 1 or not injective. It is not injective. Correct alva? So hege prove ಮಾಡೋದು 1 1 hege check ಮಾಡೋದು? Take f of x1 equal to x2, f of x2. If you are able to prove x1 equal to x2, then it is 1 1. If x1 is not equal to x2, then it is called onto. The second one, the next one onto andre surjective. Okay, so already you saw in examples. Take one condition directly. F of x is equal to y. F of x x square is equal to y. See, this y is belongs to the codomain. This y is belongs to codomain. So x square equal to y. X is equal to plus or minus square root of y. Now check whether this is always an integer. Why? This integer is nothing but domain. This is a domain. If this is true for all y, if this is true for all y, then it is onto. If it is not, it is not onto. Whether it is always an integer? No, because of square root, easily you can identify that. Usually you can give an example where this number is not an integer. So if you want to say it's no, you should give an example. Take y is equal to 2. X enagate plus or minus square root of 2. Is it belongs to z? No. Over, if there is a one element not connected to the domain, then it is not onto. Therefore, f is not onto, or f is not surjective. F is not surjective. So this is an important question. So what we did here, we proved it is not 1 1 as well as it is not onto, or we proved it is not injective, it is not surjective. I hope you understood. Okay, the next question. F from z to z given by f of x is equal to x cube. F from z to z, f of x is equal to x cube. Observe money, x cube is x square ala x cube. So same procedure, we have to divide this work into two work. The one, okay, you're going to check whether it is 1 1 or not. Next, you're going to check whether it is onto or not. Okay, so first I'm going to check whether it is 1 1 or not. Okay, 1 1 andre no. Okay, if images are equal, then elements should be equal alba. Take two different images, okay, or assume f of x1 equal to f of x2. F of x1 enagataga x1 cube, idu x2 cube. Takes cube root on both sides. So this implies, is it plus or minus x2 or just x2? Here don't write plus or minus x2, here just x2, not plus or minus. So immediately this implies you can write, images are equal, elements are equal. So what is the conclusion? F is 1 1. F is 1 1 function. Then f is 1 1 function. Here plus or minus illa. Why plus or minus not there? Cube root. Only you are getting plus or minus for square root. Cube root ik barala. So x1 equal to x2. So f of f is 1 1 function. Now you have to check whether it is onto or not. Same procedure. Ella problem onde procedure nenpilla. Pattern nenpirli. Okay. First ಏನು assume ಮಾಡಬೇಕು? F of x is equal to y for y belongs to codomain. Okay. What is f of x? X cube is equal to y. X is equal to cube root of y. Plus or minus illu illa nenpeli, don't write plus or minus, it's just cube root of y. Now you have to check whether this belongs to z for all y belongs to z. You have to check whether it is belongs to z or not. If you think it is not belongs to z, okay fine, but you must be able to give an example. If you are not able to give example, then you should agree that it is belongs to z. Can you give me a value of y so that cube root of y is not an integer? You will get so many, right? Let it be 7. 8 tagolboda. If you take 8, what will happen? Cube root of 8 is 2. It is an integer. So take a number y such that cube root of that is not an integer. So let it be y. So if y is equal to 7, x enagate cube root of 7. Is it an integer? Definitely no. So f is not onto. See, in this particular problem, you verify that f is 1 1 but not onto. F is 1 1 but not onto. Clear? I think that problem. So first one is f from z to z f of x equal to x square. Next one z to z f of x equal to x cube. X square not both 1 1 and onto, but x cube and 1 1 but not onto. The next question. Show that function f from r to r star to r star defined by f of x equal to 1 by x is 1 1 and onto. ಇಲ್ಲಿ r star ಅಂತ ಹೇಳಿದ್ರೆ ನೆನಪಲ್ಲಿ set of all non-zero real number, real number. See here answer is given actually, and let's show that question, the answer will be known that it must be 1 1 as well as onto. So you have to prove it is 1 1. So let me start with the first one, 1 1. We have to check whether it is 1 1 or not. Okay, so here take the images are equal. Let us assume that images are equal, correct? So 1 by x is equal to 1 by x2. Cross multiply agate x2 is equal to x1. If images are equal, elements are equal, then you know that f is 1 1, correct? No, f is 1 1. So we proved that it is 1 1 function. Next ಏನು prove ಮಾಡಬೇಕು? onto. We have to prove that it is onto. We have to prove it is onto. Okay, let us assume that f of x is equal to y for y belongs to the codomain r star. What is f of x? 1 by x is equal to y. So x is equal to 1 by y. Is it always belongs to r star? Yeah, it must be. Why? 1 by y cannot be equal to 0. Okay, cannot be 1 by y is not equal to 0, and 1 by y is always r star belongs to real number because y is not equal to 0. So because of this you can say that f is onto. So we proved f is both 1 1 as well as onto. So it is asked in this particular question, show that f is 1 1 as well as onto. R suffix star andre set of all non-zero real number and 0 include agilla. Artha aithalva? This is an important question. Easy to prove 1 1. So be careful with onto because a little confusion. So be careful. Okay, onto case. So I'm moving to the last question of this video. Okay. The last question in this list is prove that f from r to r defined by f of x is equal to greatest integer function. Did you remember what do you mean by greatest integer function? ಈ symbol ನೆನಪಿದೆ ಅಲ್ವಾ, ಫಸ್ಟ್ ಪೀಸ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ, greatest integer function. Now we have to prove that it is neither 1 1 nor onto. You have to prove it is not 1 1 as well as not onto. Okay, so let me start from 1 1. Okay, you can't use a definition here to prove it is 1 1. So you give some example. ಈ ತರ prove ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದೆ. So give one example. See, for example, f of 1.1, greatest integer of 1.1 ಏನಾಗುತ್ತೆ? 1. f of 1.2, greatest integer of 1.2 ಏನಾಗುತ್ತೆ? Again 1 only. So two different elements. See, observe carefully. 1.1 is not equal to 1.2, but f of 1.1 is equal to f of 1.2 alva. So what we proved? Two different elements, two different images, okay, will match, but elements does not match. Okay, so 1.1 is not equal to 1.2, therefore f is not 1 1. Easy. One example kotbidi bowl. So two different elements but images are same. Two different elements are different, okay, but images are same. So such function, example clearly show that f is not 1 1. Now you have to check whether it is onto or not. See, in one different method use ಮಾಡ್ತೇನೆ ನೆನಪಲ್ಲಿ. We didn't use up to now this method in the previous problem. See, if the function is onto, remember, if the function is onto, then the range must be equal to codomain. Why? Definition of onto, every element of the codomain must be related at least one element in the domain. No, so ಎಲ್ಲ elements codomain relate ಆಗಿದ್ರೆ what is the range? The codomain itself. So tell me first the range of this function. What is range of greatest integer of x? Then range output is z, right? Range is z. But what is the codomain of this function? The codomain, but codomain is r. Now r is not equal to z alva. set of all real number cannot be is equal to z, because z is a smaller compared to set of all real number. So in a conclusion, range is not equal to codomain. This clearly shows that some elements in the codomain are not related to any element in the domain. This clearly shows that there exist some elements in the codomain which are not related to any element in the domain. So in a conclusion, f is not onto, therefore f is not onto. So we proved it is not 1 1 as well as not onto. I hope you understood. So few more problems are there that I will continue in the next video. Thank you.